Hi, everybody. My name is Gerald Venzl, and I'm a Senior Director here for Oracle Database Development. Welcome to my session, What's New for Application Development with Oracle Database. Let's jump right in. The next version of the Oracle Database will be 23C, taking us directly from 21C to the next version of the Oracle Database, which also happens to be the long-term support release. So if you're a developer or anybody using Oracle Database, 23C is really your next version that you want to go with. What's really important, if you're upgrading when you're upgrading to 23C, you can only upgrade directly from 19C or 21C to 23C. Of course, you can always export, import, and go to the latest and greatest version of the Oracle database, but the direct upgrade path will only be supported for 19C or 21C. So if you're ready on 19C or 21C, which you should, because 19C is the current long-term support release and the 21C is the current innovation release, you're all good to go. If you're on a previous version of Oracle database, you may have to use other techniques to upgrade to 23C or upgrade to 19 and 21 first. Now, a lot of people like Oracle database. There's a lot of good features in the database that makes it the best database on the market. Let's take a look at why developers like Oracle database. First and foremost, Oracle database is unique in its converged database capabilities. What it means is that we don't only offer you multiple data models to store in the database, such as relational, JSON, graph, XML, and so forth, but also the capabilities of the operational aspect. So you can apply not only SQL over all of these data types or SQL in combination with all of these data types, aka write a SQL statement that joins over JSON and relational, but you can also apply the same security principles. You get the same high performance, scalability, high availability, and security aspects of the Oracle database. Hence, it makes it a true converged database and sets it apart from the multi-model databases out there. Of course, developers like APIs. That's what they use every day to write great applications. Oracle database is unique in its capability of providing standard APIs. Not only SQL, which of course is standard since a long, long time, but also standard APIs for other interactions, such as using the database as a document store or using Sparkle to write spatial analytics and so forth. Another unique feature of the Oracle database and really liked by developers as well as the business analysts is the local platform Apex that we ship built into the Oracle database. If you want to write a web-based application real quick, you can do so with Apex without having to write lines and lines of code. You just leverage the tool, put together your reports. It's right there on top of your data inside your database, accessible to anybody in a browser. That's why it's so popular with developers out there. And of course, last but not least, really important aspect, why do we store data in a database to begin with? Well, because we want to retrieve and analyze the data. And Oracle is number one when it comes to integrated analytics. I've already mentioned it before, the capabilities to be able to have a SQL statement go across JSON and relational, but it goes much, much further into deep analytics and real-time analytics that it can run with Oracle on top of any workload, on top of any data type. Now, of course, Oracle database is also loved by operations, which again makes it the number one database on the platform. So if you're a developer, you have all the toolbacks that you like, but the operations people will also like you for choosing Oracle database. You know, no surprise here. Why do operations like Oracle database? For all the reasons that made Oracle database the best database out there for the last 30 years. You have the fastest performance, the highest availability, the strongest security, and the most scalable platform. When we look at 23C, there are two key goals that we drove for application development. What do we want to make different for and to deliver for developers when building new applications that require a database? Over the last couple of years, we have seen a lot of databases emerging, a lot of those being single-purpose databases, like something like a Keyvalue store that allows you to just park data in Keyvalue, or document stores that only allows you to store JSON. In the very beginning, when we saw this trend emerging 10 to 12 years ago, we already said this will not be enough for developers. These point solutions are great, but there has to be more than just like a one-trick pony for one specific workload or data type. And as we see now, the proliferation has indeed taken place, and now these so-called, or back then so-called single-purpose databases are now going into the multimodal databases, which I've mentioned just before. And again, we think they are still behind, that what people really want is a converged database methodology, a technology where you can apply all the functionality and features on all of your data. Now, looking at the last 10 years, we had a lot of proliferation. We had a lot of choice out there. The world has gotten quite complex for developers and IT people in general. So what are our key goals, or what were our key goals for the next version of the Oracle database? 2, increase productivity, increase simplicity. Do more with less and make it easier than ever before to do so that you can focus on writing great applications and provide business value to your company or to your customers, and not having to work around with 10, 15 different technologies to deliver one use case to your customer. So the key theme for up there for Oracle database, again, productivity and simplicity. Now, 23C has over 300 features coming. And again, it's long-term support release. You get a lot of features, and you get the next long-term support version that you will run your business on or your applications with for a long time. Here's just a tiny glimpse what's coming in those 2 buckets, or these 2 focus areas that we have talked about. But of course, we cannot cover 300 features in the time we're having. So picked out a couple of highlights alongside those lists, or in addition to that list, that I want to drive deeper on, that helps you to be more productive and make application development simpler. So let's jump right in. One feature that's coming with 23C is schema level privileges. What are schema level privileges? Well, it's the ability to grant access to an object type for a schema. So what that means is you can grant any privilege on a given object type to the entire schema. So let's say you have schema X and you have multiple tables in there, and you would like to grant the ability for another user to access any table in the schema X. What you had to do before this functionality was either grant the select any table for the entire database to that user, but that meant that user can now select not only from schema X, but also from any other schema, or you had to grant select on every table in the given schema. Now that in turn was not too difficult to do, but every time you added a new table, you had to make sure that that grant came along as well. So it made it a little bit convoluted and a little bit more of a hassle to ensure that every table in a given schema can be selected, regardless whether it's added after the fact when you have granted those privileges or not. So when we look at code, on the left-hand side, we have what this looked before, right? Either grant select on any table to that user, which means that user can now select any table in the entire database, or grant select on every individual table in that schema to that user. Starting with 23C, you can grant select any table on schema, whatever that schema is that you want to grant. And that's not only for tables, but for any object types. So the same is true for whether it's for execution on procedures or access to views, etc., etc. All these privileges that you had on database level, all these any privileges, are now also available on schema level, which means if you ever add a new table, in this case to the prod schema, the HR user will have automatic access to that new table because it has this grant on any table to the schema production. Super helpful for simplicity, and of course also drives productivity to get on back to writing your applications rather than trying to figure out the privileges required to make your application run. Another really cool feature is, a personal favorite of mine, is annotations. We will provide the capability to add metadata to your data and your data model, which means you can annotate tables, views, columns in these tables or views, indexes, domains, and many, many more. What it allows you to do is to store keys or key values alongside to your data model or data that you then either as the user, the DBA, the developer, or the application or applications accessing the data and data model can make sense out of. Let's jump in what this looks like. So annotations are free text keys or key value pairs. So you can store whatever you like in there. So here's an example where we add annotations to a table. So we have a table, we have the new annotations keyword with parentheses, and now we add a key value pair that says sensitivity is the key, the value is high, it's just a string as you see. With departments as a key, a string is a comma separated list. You can store anything you like in that string. And we have just a key front office, but we don't need any further value to it. What allows that to do is for you to make sense out of the data, right? And you depends again whether it could be the DBA, the developer, the front-end user, or the application. An application can go ahead and parse these annotations and make sense out of it. And let's say all the applications agree, hey, we have a key sensitivity and we rank it low, medium, high. And depending how we rank it, we may want to do something different in the application itself with the data. Maybe we don't show it to everybody. Maybe you need an extra privilege in the application, etc. So this goes further though. You can annotate a set on pretty much any object and of course also on the columns of a table. So here's the same example with another table where we have 3 columns, ID, name, salary. And we annotate each of these with free text key value pairs. On ID, we call out that it's an identity, and we park information of how we want to display this in the application. We don't want to just show an ID column, but we want to show employee ID and which group this belongs into. So you can go on and on about this, but it gives you a real powerful mechanism of what it allows you to do or what information allows you to store alongside your data model. I hope you're all really excited about this. Another real cool feature that we're introducing is SQL Domains. Domains is a mechanism to store additional information about the data that we store. Now, what do I mean by that? Let's be honest. A lot of data goes beyond simple data types, right? Email addresses are strings, yes, but strings with a special format. You have to have the @ sign in there, you have to have the domain at the end, and so forth. Credit card numbers are numbers, but with a very certain length and requirement. Zip codes or postal codes, depending where in the world you are, can be numbers, strings, a combination of both. Now, when you store that information into a data type, we can store it as a string, a number, etc., right? But what about the additional information? What makes a credit card number a valid credit card number, right? It can only be certain digits long. It's like we can store a certain amount of range of digits in the number data type, but how can we ensure that it can only be those 15 or 16 digits that credit makes it a valid credit card number? Domains allow you to abstract this domain-specific knowledge into a reusable object and then provide special constraints, display, ordering, and annotation attributes on top of it. Now, what does that look like? So you get a new database object or object type domains that you can specify and create and then add these attributes. So let's take the example of an email address. It's like you probably store email addresses all over the place, right? It's like maybe for the customer, when a delivery goes out, etc., etc. Every time you want to store an email address in a table, you would have to repeat these either checks or constraints or further analysis or business rules to make sure it's a valid email address. Now, domain allows you to abstract that. So here on the bottom, we see we create a new domain called email. We tell the database that this is of type varchar 225. We add a check constraint on it, making sure that there's an @ sign and a dot at the end of the domain name, the .com, .net, etc. And then we add a couple of more properties to it, like a certain way how we want to display it. For example, if somebody wants to display that email address, they shouldn't see the first and last name or anything that's before the @ sign, just the domain itself. And we also add ordering to it. What we do by the ordering is we first order by the domain name and then by the names, because when you want to look through all the email addresses, you want to probably see the email addresses that belong to the same domain first, rather than just sorted by the first few letters in the email address. So what does this look like? We have a table customers, and you see we have here 2 email addresses, a contact email and an invoice email, right? People sometimes want to be contacted on one, but sent invoices, etc., on another email address. So we're using this domain now, and here you already see right there that there's no need for recreating the check of what an email is. We can just reuse this domain. You specify here varchar2 1000 in this case. The domain will ensure that it's at least 255 bytes of varchar2, but you can go bigger, of course, and overwrite this thing. Actually, I want to store 1000 here. And then you specify this as keyword domain, and the domain name. And when you try to insert the value into this table, you'll see here we actually try to insert invalid email addresses. And we see that this check constraint that we have defined before fires and says, hey, this is not a valid email address because the regular expression it fails. But again, it goes beyond. Like, what about these display or ordering information? Well, you will get two new functions, domain display and domain order, where you can apply these attributes that you've specified on the domain on the data. So if you do a select domain display here, for example, on the invoice, you see that we get this dash, dash, dash at, and then the domain names in here. If we do the domain order on, let's say, the contact email address, well, there, remember that we actually said, okay, we want to display based on you expect Michelle Swarovski based on the ordering, but on the domain display over here, you will actually find that the Swarovski goes before the shell. So like there is some power to this, and it allows you to abstract or encapsulate certain knowledge of how you want to use the data. Now, the column itself is full on a regular column as you would always have. So if you were just to select the invoice or the contact email without these functions, what you get back is a varchar2 1000. All right. So like everything that works naturally, and that's the reason also why we add this keyword domain after the data type. But if you want to actually go further and leverage these domain attributes, then, I said, like display order, annotations could be on top of that domain as well. Then you can use these new functions, and it allows you to derive this domain specific knowledge of it. So you get the best of both worlds. So it's like you can store it the way you always stored it, deal with it you always did, but you can add domain expertise to the data that you're storing, which makes it a really, really powerful tool and technique for you to have, but also because it's a reusable object. Again, it drives productivity and simplicity all over. Now, short but sweet, like Oracle database up to now had a limit of 1,000 columns per table. That served us well for a long, long time. So especially in the data science world, where you kind of want to have just load the data, you have it denormalized, you have very wide tables, very wide columns. You may find that 1,000 columns is not enough. So what have we done in 23C? We have extended the limit that you can now have 4,096 columns in a table. Now you have to have compatible set to 23C to enable this, of course, but there's also another parameter that guides whether you can have 1,000 or 4,096 columns in a table, which is called max columns, and which has to be set to extended. So if you ever have the need to have broader tables, wider tables, go and check this parameter, set it to extended, and now you can store up to 4,096 columns in the database, or in a table in the database. Another really cool feature is Json Schemers. So obviously Oracle database has done a lot in the JSON field for the last 10 years with the introduction of JSON in 12.102 back in 2014. And we have just introduced the JSON data type in 21C. Now we're driving this one level further, where we allow you to validate JSON against the given JSON schema. And the way how you can do this is like either on storage time or persistence time, but also on query time or runtime. So what I mean by this is like you can either define schemas on columns on a table. You see here the example to the left. We have a create table, and we have a JSON column doc where we use the JSON data type. And then we have a new validate keyword, and then just the string of that JSON schema that you would like to validate against. Or you can do the same thing at runtime when you have a select, where you select from a table containing JSON. You say, okay, this column doc is JSON, which is already a keyword that you already have. So validate that it's a well-formed JSON format. And then again, the validate keyword where you put in the JSON schema. In this case here, we're checking that we have an object where there's a property called ID that it's of type number. Now, doesn't have to be a string. The JSON schema could sit in another column, for example, as well, and you just validate against the column. Wherever you want to store the schema is up to you. This gives you a lot of flexibility of how you want to use it, whether you pass it in via parameter, whether you store it in a central table and reuse the schema, etc., etc. Additionally to that, you can validate, or you can get a report of the validation, what failed in the schema validation, right? It's great to know, hey, this JSON document does not adhere to that schema that we have. If you have it on a column, we will not allow you to store it as such. Or it's also great to say, hey, we have JSON data in there. Let's see actually what columns actually do adhere to the schema and what not. There's a new package, DBMS JSON schema, with quite a few subroutines in there, but one very helpful one being the validate report. And the validate report allows you to apply the JSON schema on the document and get the report out of what's wrong, of what the validation failed or not. So here again, we're selecting from a table JDocs. We just use this function validate report on our column doc where the JSON's in, and a column schema where we store the schema. And we see here in the report output, which happens to be JSON format as well. So it's very easily reusable if you're in this JSON field, that valid is first and foremost false. So if it were true, we could probably stop right there and wouldn't get much more. But in this case, valid is false. We have here a property ID that is actually a string and not a number. And so hence the validation fails. Really powerful mechanism, really powerful tool. And again, helps productivity a lot. Another data type that we're introducing with 23C, sometimes long sought after or looked forward to, is the Boolean data type. So 23C will have the Boolean data type. You can now just specify columns as Boolean and then store Boolean values in there. And you get everything alongside with it as you expect. So you can see, as we have here, we store email addresses here. We have a Boolean column active, whether the email address is still active or not. And you can then just say select address from emails where active. Now this will just see, okay, where is it true or false? But additionally to that, you will get also implicit conversions. So like a string yes or no, or 0 or 1 will be converted as well. Really, really powerful tool, really helpful. And something, Boolean data type, something people have long looked forward to. Now the simplicity aspect, update via join. So you can now update tables, base tables, or tables based on foreign keys or foreign table conditions. So you could do this before with in clauses or subselects, but now you can just say, okay, update employees, increase the salary, and then you join to the departments because you want to give a salary rise to everybody who is in the department development. So super powerful, super simplicity, super simple to now do updates based on a condition in another table. JavaScript store procedures. So in 21C, we introduced the multilingual engine, or MLE, and allowed you to execute JavaScript evaluation, so evaluation of JavaScript code, and use this in PL SQL. With 23C, we go the next step, as we've promised, and provide you the capability to store JavaScript in the database. Now, there's a couple of ways how you can do this. In this case, we will have new MLE modules that you can run or store or import your JavaScript in. So let's say it could be an npm package, or in this case, we have here a module called JS module with 2 new functions, concat substring, and then we create function definitions on top of that are callable. In this case, a new function called JS concat, where we pass in our PL SQL or SQL parameters, the return parameter, and then go into the module and provide this call signature of the function concat. And then, as you see, we can just then from this point on say select JS concat and provide 2 strings here, 2 parameters here, and we execute JavaScript and get out the string concatenated hello world. Super powerful, allows you to full on use JavaScript and reuse JavaScript in the database. If not exist, a nice little helper, especially in the test and development environment. For example, if you were to have tests that you want to run, you would always have to say, okay, if you want to start from a clean state, okay, drop this table if it were there, right? And then recreate the staging table. I always want to kind of have this test table, staging table, whatever it is, recreated when I restart my test. Now, the crux to this is if your test was successful, that drop table statement will throw you an error that the table of view does not exist that you tried to drop. Now, if you were unsuccessful, the crux to that is that you basically, if you won't have the drop table there, that create table will tell you, hey, there's already a table there used by an existing object. So what can you do now? You can specify this if not exists or if exists there, which will ignore this error. So for example, you can say drop table if exists. If the table isn't there, it will just carry on. So therefore, you can use this in the test script and just or never ever have this drop table statement cause an error in case there's a false negative. Basically, you drop the table while the table isn't there. You don't care that the table isn't there. It's just there's a safety net to make sure you start from scratch in your test. Super little powerful helper here to make just your, especially testing environments, easier to use and more productive. Group by column alias and position. Prior to that, something that people have asked for a long time. When you had something like an expression in your group by, well, here we extract the year from the column hire date, you would have to repeat this in the group by and having clause to reuse. If you were just saying here we call this column actually this expression hire date year, we cannot reuse that in the group by or having clause. It would have thrown you an error. Starting with 23C, you can reuse that. So you see here this hired year, you can just use this column alias and group by and having by clause. And you could do the same thing by position if you want to guard a parameter to go over this. So meaning like an order, like you would have with an order by as well. So group by 1, 2, 3. Super powerful, super nice little productivity helper. Table values constructor, table value constructors, ANSYS ISO SQL standard functionality that allows you to create multiple values at once. What it means very simply put, on the left-hand side, you have an insert into bookings. You would like to insert a couple of rows at once. In the past, you could have to specify an insert into every time for each row. Now you can just go ahead and say multiple values, 1, 2, 3, 4, in one insert into. Or you can use the values constructor to generate values like on the right-hand side, where you select from these values 1, 2, 3, you tell us what the columns are, and it generates you columns, rows 1, 2, 3. It's very powerful where you can use this value constructor. That's why we have gone ahead and also introduced a new execution plan operation called value scan. So whenever you use the values constructor in a SQL statement, you will see this new operation value scan. And we will tell you underneath which table value constructor was used, which values of these were used. You see here on the right-hand side, the values are the same that you have here on the left-hand side in the second statement. Enhanced returning clause, also something long sought after. Returning clause was introduced originally to return the IDs of insert statements of primary keys. Now you can return values for all DML statements, insert, update, delete, and merge. And you can return old and new values for all of them. If you don't specify it, by default, you will just get the new. But you could now go ahead and say, for example, for an update clause, as you have there, well, please give me the old salary and the new salary. And then you know actually what the value was prior to the update and post the update. Super powerful, super helpful. You can now apply this on all DML statements. Developer role, a nice new easy way to grant necessary privileges for a developer in one command. UMS developer admin grant privileges. It includes system and object privileges. So there's all the privileges that we think are useful for a developer to get going and build their applications. So you see the complete list of system privileges here, create tables, create procedures, etc., but also object privileges such as being able to see execution plans, SQL monitoring, stats for your session, and so forth. So that will make it really helpful and powerful for developers to just, have the necessary privileges to build the application without having to grant DBA or not knowing which privileges to grant. Super easy little productivity helper. Select without from. If you select on expressions, there's no longer the requirement to specify from dual. Tiny little keystroke saver. So if you were to just select the sysdate, well, the sysdate is not coming from a table. So it's an expression, it's a function that you use. So there's no need to say from dual anymore. You can just do, as you see here, select sysdate or any expression or function call without from dual. But the from dual still exists. You can use either or. It's just a little keystroke saver that you can use or not. Last but not least, in 23C, you will get a lot more better error messages. So here, a very famous one. If you miss a column in the group by, you will get a not in a group by expression, but it doesn't tell you actually which column is not a group by expression. Which one was it? Well, starting with 23C, we will tell you, hey, no, in the table of sales, the state column, this does not match the group by condition, the group by expression, making it much easier for you to spot, I forgot the column state in my group by expression. Or converting a number. It's like prior to 23C, you got invalid number. Well, what was the invalid number? What did I try to convert, etc.? Well, starting in 23C, we will tell you that you are unable to convert the value ABC to a number, making it quite obvious right away why the conversion failed. But also, of course, like if you were to have any kind of two number on a column and so forth, you will get to see why this conversion failed. Select from a table that does not exist. All you get is select table of view does not exist. Well, which table of view does not exist? Selects can be quite long. There could be quite a lot of tables in there and subselects and so forth. Which table of view does not exist? Well, we'll tell you which table of view does not exist going forward, making it much easier to immediately spot whether you had a typo in there or some table that you that isn't there, you don't have privileges on. And last but not least, connecting to a database name that is not there. Either you have a typo or you used an invalid database name. Here said not a valid DB name. Well, prior to 23C, you get TNS listener does not currently know of service request in connect descriptor. It's like what I really should say and will say going forward in 23C, cannot connect to database because the service not a valid database name, DB name, is not registered with the listener at that host on this port. So you either have a typo there or the service you try to connect to simply does not exist. So again, like all of this put together, 23C, the next long-term support release, productivity and simplicity for application development, really the release to look forward to and upgrade to as moment it comes out. I hope you have found a lot of things here that you're excited about. We certainly are. I personally am as well. And with that, I would like to thank you for your attention.